Today we will start RBD, rigid body dynamics. We have already done the circular motion. In circular motion, the angular displacement, angular speed, angular acceleration, and so on. We have already done. Now we will start from here. That's angular velocity. The angular speed of an object is omega, and linear speed is v. Then the relation between omega and v is omega r. If angular speed is omega and linear speed is v for an object moving on a circular path of radius r, moving on a circular path of radius r, the circle having radius r, an object at this point, this one is radius r, this is center, this is speed, linear, velocity is v. Now we want to find the relation between angular velocity and linear velocity. Now the direction of angular velocity is always given by right hand thumb rule, or angular velocity is axial vector. The direction of omega is always given along the axis, either upward or downward. For example, object is moving on this circular path in this direction. This is the axis of rotation. Then omega will be along the axis in the upward direction. If object is moving anti-clockwise, this is the axis of rotation, then omega will be downward by right hand thumb rule. Now we want to find the relation between angular velocity and linear velocity. This is the circle on which the particle is moving, the center O, the axis of rotation. This one is axis of rotation. Suppose origin at this point. Here is origin. At any instant object at this point A is the velocity v along the tangent, linear velocity. This will be the position vector. That's r. That's the position vector. This one is radius r. The direction of omega will be this one because object is moving anti-clockwise. This one is omega. Suppose the angle between the axis of rotation and the position vector is theta. We very well know that v is omega r. Here is r is the radius of the circle. We want to convert r, small r, in terms of position vector, that's capital R. So in triangle O, O dash and A, we can easily find the sine of theta will be perpendicular, that's r upon capital R. The value of r will be r sine of theta. On putting this value in relation v is omega r, so we get v will be omega and r sine of, we can also write in vector form. In vector form, v vector is omega r sine of theta and n cap. Here n cap is the unit vector along v. Here n cap is the unit vector. By right hand thumb rule, we can easily write v vector is omega cross capital R. Here capital R is not the radius of the circle, but the position vector of the object. If origin is at the center of the circle, of the circle, then small r and capital R will be equal. Small r is capital R, so it becomes, so V will be omega cross small r. This is the relation between angular velocity and linear velocity. Now the torque. If an object is free to rotate about any axis and if we apply the force on the object, then it will rotate. The tendency of this rotation depends only on the force. This tendency is known as the torque. It does not depend only on the force. It also depends on force and the perpendicular distance from the axis of rotation. For example, I want to open the door with the help of the handle. We must apply the force. If the handle is near the axis of rotation, then much more force must be applied to open the door. It means to open the door, only force is not sufficient. It also depends on the distance of the handle from the axis of rotation and the force also. This combined effect, force and the perpendicular distance at which force is applied from the axis of rotation, is known as torque. An object is free to rotate. An object is free to rotate about an axis. If we apply the force on the object, the force on the object, then it will rotate. It will rotate. The tendency of rotation is known as torque. This tendency of rotation is known as torque. Its symbol is TAW, T-A-W. For example, this one is any object of any shape. It is free rotate about this axis, which is passing through this point. This is the axis of rotation. Axis of rotation. The point O, passing through point O. At this point, a force is applied in this direction. The force F is applied. The distance between the force, point of application of force, and this axis, this one is R. This time this one is origin. The angle between R and F is theta. This one is theta. Why? If we extend this R, then this angle is theta, so this angle will also be theta. Now we want to find the torque. Torque is written as force into perpendicular distance from the axis of rotation. Distance from the axis of rotation. In mathematical form, TAW will be force is F and perpendicular distance. So this point is P. This O to P is not the perpendicular distance, so we will draw a perpendicular from O on force. Suppose this point is M. So OM will be the perpendicular distance. This angle is 90 into OM. Now we want to find the value of OM in terms of R. In triangle OPM, in the triangle OPM, sine of theta will be OM divided by OP, means OM is OP and the sine of theta, that's R sine of theta. We put the value of OM in the form this 2, so 2 becomes F R sine of theta. It means the value of 2 torque, tendency of rotation depends on F as well as on R and angle of theta. You can also write, suppose this relation number is 1. So, in vector form, 2 will be F R sine of theta n cap. Here is n cap is the unit vector in the direction of torque. Here is n cap is the unit vector in the direction of 2 of torque. By right hand thumb rule, we can also write vector form 2 will be R cross F. This is the required relation between the torque, force and distance R, perpendicular distance. That's here by the right hand thumb rule. This is given by if we points the fingers of our right hand towards the first vector and rotate them in the direction of rotation of the object. For example, fingers of right hand, spread the fingers and our thumb in such a way that they are mutually perpendicular and points the fingers towards R and rotate the fingers in such a way that they will rotate in the direction of rotation of the object, and thumb will be upward. This will show the direction of 2. On figure, the direction of 2 will be in this direction. That's 2. So, first vector is R. So, in vector form, it is written as 2 is R cross F. R cross F. Now, there may be 3 cases. Number case 1, if theta is 0 degree, then 2 will be R F sine of 0, because sine of 0 is 0. So, 2 will be 0. Meaning the angle between the R and F is 0 degree, then the value of torque, tendency of rotation will be 0. Now the case second, if theta is 90 degree, then 2 will be RF sine of 90, that's only RF, maximum value of this one. Means the angle between R and F is 90 degree, then torque will be maximum. Now in case third, if theta is 180 degree, then 2 will be R F sine of 180, that's cos 90 again, because sine 180 is sine 90 plus 90, that's cos 90, or cos 90 is 0, torque will be 0.